All right, so in this lesson, we're going to be actually combining two different parts of your textbook, 10.5 and 10.6. They both deal with something called scientific notation, and I felt that we should combine these together because really they do go together. It's about reading and writing in scientific notation. So your goal is to understand what numbers in scientific notation represent. All right, so let's start taking a look at things. Let's say you're in some economic or business situation and you're looking at this information. A corporation made, let's see, thousand, million, billion, trillion, $4 trillion in revenue. Now, if you were in economics or an accountant or somebody who had to deal with these types of really large numbers day in and day out, it would be kind of a hassle to have to either type in or write out this number all the time. And so that's what scientific notation was invented for. Scientific notation is a shorthand way of writing out this number. And basically, here's how it goes. Is another way to think of this number is to take this number 4 and to realize that this is just 4 times 1 trillion. So if I take out the trillion parts separately, I can write it here. Now, that doesn't shorten up our number at all. In fact, it makes it a little bit longer. But the shortening part is to realize that this part, the trillion, is nothing more than factors of 10 being multiplied together. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, so on and so forth until I get to 1 trillion. So if I could figure out how many factors of 10 this is, I could then represent it with exponents. Now, it turns out that 1 trillion is just 10 times itself 12 times. And so what this becomes is 4 times 10 to the 12th power. Okay, and this is what's called scientific notation. It's just basically a shorthand way of writing out really long numbers like the one we've got here. All right, let's see another example of that. All right, so let's say you're an astronomer. You deal with planetary bodies and orbits and distances to suns and things like that. And let's say you're dealing with this fact. Neptune is 2,800,000,000 miles from the sun. And what we'd like to do is to change this into a shorter version, into scientific notation. Now, here's something I want you to think about. Let's say you decide to do it like this. You see the 2 and the 8, and you made it 28 times, let's see here, 1, 2... 28 times 100 million, which would then convert into 28 times 10 to the 8th power. All right, so this would be your answer. But let's say somebody else in your company, your lab, did it a little bit differently, and they chose to do 280. So they have 280 times 10 million, which would then convert into 280 times 10 to the 7th. All right, well, scientists realized that this was going to be a problem. If there was no standard rule for doing these types of problems, that we would have this confusion where one person does it this way, gets 28 times 10 to the 8th, different person does it and gets 280 times 10 to the 7th. And so which of these would be considered scientific notation? Well, let's take a look at that. Let's take a look at the textbook definition of what scientific notation looks like. Okay, now, there's no mathematical reason for this. This is what was just chosen so that this kind of mix-up doesn't happen on a regular basis. Now, scientific notation looks like this, that this leading number here, which they call the factor, that factor, when you're all finished, in this case 8.3, that number has to be greater than or equal to 1 and less than 10. Okay, so if this was a 0 here, that wouldn't work because the factor had to be greater than or equal to at least 1. And then this number couldn't be 10 itself because it needs to be less than 10. So you have to move the decimal to create that situation where this number becomes somewhere between 1 and 10, where you can be equal to 1, but not, it has to be less than 10, so not 10 itself. And then over here, then that we have all the factors of 10 we've taken out, and then this power is just some integer number that tells us how many powers of 10. Now, notice the negative here. We'll talk about that a little bit later.